You've probably heard a lot of people say that downcasting is a code smell. I'm one of those people, so let's talk about why that is. So downcasting is a form of typecasting, and typecasting can roughly be said to be the idea of taking an instance of one type but treating it as an instance of another type. Roughly. So typecasting is not specific to object-oriented languages, but downcasting and upcasting are usually found in languages that support hierarchical data types, or polymorphism. But before we push on further, let's make sure we are on the same page on what downcasting and upcasting is. So let's do a classical animal example. Let's say that we have an animal superclass and a cat subclass. So cat inherits from animal. So if you have an animal, but you treat it as a cat, then that is downcasting. If you have a cat and you treat it as an animal, then that means it's upcasting. So in that sense, it's very simple. Downcasting casts down the inheritance chain, and upcasting casts up the inheritance chain. And up means up towards the superclasses, and down means down towards the subclasses. We'll talk about upcasting some other time, but let's now focus on why downcasting is considered a code smell. So if you think about the animal example that we just talked about, the problem should become quite apparent to you if you just think about it a bit. Think of it this way. Given the system that we've designed, every cat is definitely an animal, but not every animal is definitely a cat. Think about it. Every instance of a cat definitely has to be an animal. But given any instance of an animal, you cannot be 100% certain that that particular animal is also a cat. Because cat is a subclass of animal, which means that hypothetically the system could contain even more subclasses that are also animals, and thus we have uncertainty. Of course, in the kind of silly scenario that I posed, we didn't actually have any other subclasses apart from cat. So in our system we could in some practical sense actually be 100% certain that every instance of an animal would be a cat, for the mere reason that we don't have another subclass that inherits from animal. But remember, as always, we're designing systems, right? We're architecturing systems, and I'm not saying that you should anticipate requirements that you're currently not anticipating, but what I'm saying is that if you use that kind of logic, I think it's fairly certain to say that you're going to be in a world of hurt a lot of times. So let me put it in a slightly different way. In some sense, I'm shocked that the idea of downcasting actually exists in serious languages that we use, such as C# or Java. If there is some kind of rational idea behind this, please feel free to outline that or point me towards some resource in the comments, because honestly, I really haven't found any good reason, but I may be wrong. However, the object-oriented language OCaml doesn't support downcasting. So at least some people seem to agree with the idea that downcasting simply isn't ever a good idea. And in case I'm underestimating the amount of people that think that, then perhaps we have downcasting in a lot of languages for legacy reasons. Perhaps people, when designing these languages, didn't realize how fundamentally insane downcasting is, put them in the languages, and people started using them. And then now we have code bases where people are using downcasting, and then we simply just keep it there. But I mean, now I'm totally speculating, I have no idea. So with the arguments that we've looked at, I'm pretty sure you already agree that downcasting is, in some sense, kind of insane. But to put one final nail in the coffin, let's look at one more example. Just think about the absurdity of this scenario. Assume that you were building a class, you were writing a class, we're on the same team, you and I, right? And you were writing a class, and in the constructor of that class, you take something that is of a type, say an animal, but then in your constructor, or later sometime in your code, you are downcasting from an animal to a cat. And then you give this class to me. And if you think about this situation from a contract perspective, right? As in, from an interface perspective, as in the boundary between me and you. So the way I interface with your code and the way you interface with my code. I mean, trying to find some agreements on interfaces is like 101 of actually trying to produce something useful in a team. So from an interfacing perspective, essentially what you're saying to me is that here's a class, you can use it the way you want, as long as in the constructor you give it an animal, right? What you're saying is that anything that is of type animal is okay. So I make that assumption, right? I take your class, I instantiate an instance of your class, and I pass something that is of type animal to the constructor. But what happens? It blows up. Because in your code you were downcasting. You were downcasting to cat, and maybe I sent a dog, right? Your contract said you want an animal. I instantiate an animal, a dog that inherits from animal. I pass you the dog, and then your code blows up because you were downcasting to a specific type. And then you may come in and you argue, okay, wait, but I could have used is instance of, I could have checked whether the thing I'm passing is of type cat, and then only in the case that it is of type cat, then you downcast, right? And you're right that that wouldn't cause an exception, but design-wise, this is insane. I won't dig into this argument in depth, but please see my other video on why type checking is a code smell. If you think about it, what's happening is that we are breaking the open-closed principle. The open-closed principle says that something should be open for extension but closed for modification. So your class, through dependency injection, is closed for extension, not only for modification. Because when you are typecasting to a cat, you're suddenly locking me in. You're saying that, okay, if you pass me something that's not a cat, then there are certain parts of the behavior of this class that you won't get to experience because it's only for cats. But that's insane. Then the interface should be that you are expecting cats, and only cats, and not animals. So with that said, I'll be quiet. Essentially, my point is this. I don't think there is ever a valid use case for using downcasting. It's just fundamentally insane. The idea of downcasting is completely backwards, completely insane. But if you have an example of where it does make sense, please shoot that in the comments and we'll discuss. But please avoid discussions of pragmatism, because if you're arguing pragmatism, then I would spontaneously argue that the cost of not downcasting is so sillily low, is so low that it's just silly to argue that it's pragmatic to use downcasting. But apart from that, if you have any good arguments, I'd love to hear them. That would be fantastic. Anyways, thanks for watching, and I'll see you in the next one.